everyone, this is Bhargav here. Today in this video, I am going to talk about my recent trip to the Science Museum in Sanjeevaya Park near Necklace Road. There were many wonderful science experiments to try out, and they are say from generating electricity by cycling to the laws of gravity. Here I am to tell about them all. So without any further ado, let's get right into this. So in this first video, as you can see, I am riding a bicycle with two wheels. In case you didn't know, this bicycle is connected to the light on the left by a thin wire on the other side of me, which is passing electricity to the bulb to make it glow. Well, the question is, what is different in that? The wires are commonly supplying electricity as usual to make them glow. Yes, but no. The real question is, from where is the electricity actually coming? It is being obtained from the wheel which is rotating while I hit the pedal. Very interesting. This saves money to buy motors. Here is another example of obtaining electricity through other forms. In this picture, I am standing near a solar panel which is very useful to give out electricity. When below the switch is turned on, the solar panel absorbs sunlight, hence giving out electricity to the unit through again the wires to make the bulb glow. This is common nowadays. In this picture, I am standing near wind chimes, which make sound when wind gushes alongside them. As explained in the signboard, four aerodynamic forces can act on an object: forward pushing thrust, backward pushing drag, down pushing weight, upward moving lift. If these four have a balance and act on an object, they make the object float, while an imbalance makes it move through air. Example: aeroplane. Now you can enjoy watching these rods as they produce sound. This can be commonly seen as in homes as decoration. Maybe you have one too. In this next one, I am standing alongside an abacus. It is a fun tool to mess around with, but mainly to do calculations. It has its own way of representing numbers. For example, in one type of abacus, we have one row of beads on the top of the tool. Let's take them as A here, and five beads to the bottom of the tool as B here, both separated by a bar. To represent one, we push one bead to the extreme left of the tool to the top of the bar, which divides the tool into two parts. Note that the bead A should not be pushed down. To represent 5, we take back the one bead and pull down the bead A to make 5. To make numbers above 5, we retain the bead in A in its position and push up one bead from B to the bar, just like 1. This makes 6. Likewise, 7, 8 and 9 are just pulling up more beads from B while A is retained. 10 is just like 1, but we pull the beads from B to the right of the column used for 1 to 9. Remember, this is only one type of abacus. Needless to say, it is a very interesting tool. Moving on, here is me making two racing wheels start to roll. The main question is, which one will reach the end point, and then why? Well, the answer is pretty simple. It's one to the left side of the camera. You may ask, they might be of different weights, which cause the variation in speed, thus making the left one roll faster. Let us understand that this phenomena is not related to weight at all, but related to inertia. In the left one, the weights are close to the middle, while in the right one, the weights are to the corners. This makes the left one having less inertia than the right one, thus making it move faster. This is an interesting experiment. This next video is me sitting on what looks like a painful torture chair filled with needles. The expectation everyone has while sitting on a chair is this, that when one sits on this chair, it will pierce him. But that's not reality, fortunately. What happens is we don't feel any pain. This is because we are sitting on the chair and distributing our weight evenly among all the needles. So, there is no pressure of weight on any of the individual needles, therefore not piercing one's skin. This suits our mind, doesn't it? In this next video, I am bending down with my ear close to an opening to what looks like a huge metal tube. One hears sounds when putting his or her ear close to the opening. The reason? Well, this happens when the air enters the tubes and causes a vibration. The vibration is higher in the bigger tube and lower in the smaller tube. This video, which is used usually in submarines, is a periscope. The tool is called a periscope. This object has two plane mirrors. One mirror is at the bottom, where I am bending down to see into, and the second one at the extreme top. As light travels in a straight line, we place plane mirrors slanted at the top and at the bottom to make the light travel to the top, thus helping us view the top part while looking from the bottom of the tube. This is an interesting tool for writing. In this picture, you can see me trying to solve some puzzles at the place. We had to align the tiles in such a way to form figures. Here in this clip, you can see me hitting plates made out of different metals which are of different sizes with a rod. The plate when hit which makes the highest sound is of stainless steel, and which makes the lowest sound is of aluminium. Rest all metals such as copper, brass, etc., comparatively make less sound. This proves that sound that an object produces depends on its size, length, and its type. Another example can be observed here, in which I hit metal pipes with two different lengths. Even though they are of same metal, they produce different types of sounds. In this video, I hit drums of various sizes and tops which are hollow in the inside. As you can observe, the drum with the smallest size produces a better and more audible thud, while the largest one produces comparatively a lower and less audible thud. The question then arises in our minds, why do they? Well, there's a simple explanation behind this phenomena, the airspace and the object. As you can see, the airspace is more in the larger one compared to the lowest one. Here, you can see me rolling a yo-yo attached to an iron rod. When one rolls a yo-yo like this and leaves it to roll down, it surprisingly jumps back and rolls itself, to again fall down and repeat the process until it gradually slows down and stops. This happens because energy can never be created nor destroyed. When it's at the top, the potential energy is observed, and while it is rolling that to the bottom, kinetic energy is observed. The potential energy gets converted into kinetic energy, and the kinetic into, you guessed it, potential energy. Very, very interesting, right? Another example is here, where if we pull one ball at the end with our hand and push it, the ball at the other end will react and move at the same speed. The interesting part is that the other middle balls do not move. If we pull and push first two balls, the last two balls will react and show off. And for the last but not the least, the rules of gravity. Here is the experiment of pushing a huge steel object from the top of a track to the bottom of the track. This may look normal at the start, but when you look further, you will notice that after you push the object down the track, it doesn't stop at the end point at the bottom, but comes back up to the track without the touch of a hand and stops at its starting position. Gravity and height are the reason why this phenomenon is taking place. Well, these are only some of the many experiments and phenomena I got to see there. I will make a video on the wonders I missed out soon on this channel. Until then, goodbye.